So let's go ahead and start Chapter 5. Chapter 5 is oxidation reduction reactions. We fondly call them redox in chemistry. And you will see all of your assigned homework here. This is the homework from the book. That's in addition to the homework on Wiley Plus, which gives you practice. If you can sit down and do all these homework problems in the book without looking at your notes and without looking in the book for help, then you'll be ready to pass the quiz or test on those sections. Now, last time we talked about the fact that we were starting a new chapter today, so I assume you went through and looked up all of these definitions. If you didn't, shame on you. What is oxidation, class?
The loss of electrons by one reactant.
It's the loss of electrons. And what is reduction? Gain of electrons. Now, did anyone define it differently? Because there are other ways to define oxidation and reduction. Oxidation can also be defined as an increase in oxidation number. And we'll talk about that in a couple of minutes. And reduction is a decrease in oxidation number. And we're going to look at defining oxidation and reduction both ways so that you can identify it as you're looking at chemistry. So, if oxidation and reduction is the transfer of electrons, what is an oxidizing agent, class? Say it louder.
Accepts electrons.
It accepts electrons, so if it's gaining electrons, what's it doing? Taking them. Yes, it's getting reduced. So, the oxidizing agent accepts electrons, it gains electrons, it gets reduced because it allows something else to become oxidized. So, an oxidizing agent allows something else to get oxidized. A reducing agent allows something else to get reduced, so it gets oxidized in the process because oxidation and reduction always go together. So if you go to Hollywood to become a star, you go there and you hire an agent. The agent makes you a star. They don't become a star. So the oxidizing agent makes something else get oxidized. It gets reduced in the process. So redox chemistry is electron transfer chemistry, and there's a lot of different kinds of chemistry that is redox, and there is chemistry that is not redox. We just wrapped up the section on metathesis or double replacement. In double replacement, we change partners at the dance. We move ions around, but they stay clumped together as one ion. There's no electron transfer, so that is not oxidation reduction. So what is an oxidation number? Only one person did this? Go ahead then.
A system of keeping tabs on electrons.
It's a system of keeping tabs on electrons by assigning an apparent charge or a fictitious charge. So an oxidation number is an apparent charge that something would have if the electrons were transferred completely. But electrons don't transfer completely, but we can think of who kind of owns the electron in a situation. So, assigning oxidation numbers, we look at the rules, and these rules are important that you learn them and you learn to apply them in the order in which they're written. You have to start at the top and work your way down because things that are earlier in this list of rules have preference and they have hierarchy. So we're going to go through this quickly, and it'll probably make no sense. Free elements in their natural states have an oxidation number of 0. Monoatomic ions have oxidation number equal to the charge on the ion. The sum of all oxidation numbers equals the charge on the species. Fluorine is -1 in compounds always. Hydrogen is usually +1 unless it's a metal hydride when it's -1. Oxygen is -2 unless it's a peroxide, and then it's -1. And a peroxide is something that has an oxygen-oxygen single bond. And the peroxides that are most familiar to us in Chem 111 are hydrogen peroxide or anything that contains the peroxide ion. So that's how you'll recognize a peroxide. So let's try and apply those rules now in terms of some examples, and hopefully that'll make a little more sense. So when we look at this, we start off and we have lithium oxide here. I glance at this and recognize it is an ionic compound, and it has a monoatomic cation, the lithium ion, a monoatomic anion. So the monoatomic lithium ion, lithium's an alkali metal, so it has a +1 oxidation number, and oxygen becomes oxide and has a -2. Now we have to check this. So we make sure that we followed the rule that it adds up to the charge on the species. 2 times a +1 is a +2. 1 times a -2 is a -2. And indeed, it adds to 0, which is the charge on lithium oxide. It's a neutral compound. Let's look at this one, sodium hydride. Well, sodium's a monoatomic ion, it's a +1, and the hydride ion is a monoatomic ion. Since it is written second, it's the anion here, so it's a -1. So +1 - 1 is equal to 0. Now, if that seems odd to you that hydrogen is on the second half, remember we said that sometimes hydrogen belongs over here on top of fluorine, sometimes helium belongs over there. So when hydrogen is hanging out with the halogens, it can behave like a halogen and form a -1 ion. Then it has 2 electrons like helium. Now, this next one is a little more difficult because as we go through the rules, you'll see we don't have a rule for phosphorus. So we look at this and say, okay, going down the list, the first thing I come to is hydrogen. Hydrogen's a +1 and oxygen's a -2. I don't know a rule for phosphorus. So I have 3 hydrogens with a +1, that gives me a +3. 4 oxygens with a -2, that gives me a -8. Since this is a neutral compound, the whole thing has to add up to 0. So what do I need in here to make a +3 and a -8 be 0? A 5, right? +5. 5 divided by 1 phosphorus gives us a +5 oxidation number for phosphorus. Now, you all know phosphorus doesn't make a +5 ion, but this is not a phosphorus ion. Often my students will look up there and get confused, and they're like, well, phosphorus should be a -3. No, it shouldn't. If it were a phosphide ion, it would be -3. But this is phosphorus lumped together with hydrogen and oxygen, so it's different. Okay, we're not making a phosphide ion. So this is the apparent charge. It appears that phosphorus lost 5 electrons because oxygen's hogging the electrons. Oxygen does that. Okay, here's hydrogen peroxide. Hydrogen's a +1. Since I recognize this is hydrogen peroxide, I know oxygen is -1. 2 times a +1 is +2. 2 times a -1 is -2, and it's 0. If you didn't recognize that that was a peroxide and you tried to put a -2 here, you'd say, well, +2 - 4 is not equal to 0, and that would tell you something's wrong. So then, because the hydrogen is higher on the list, we put the hydrogen in first, and then we make the oxygen be what it needs to be. So that's another way to tell it if you don't recognize that it is a peroxide. Okay, let's look at these. Dichromate. We don't have any rules for chromium, but we have an oxygen rule. Oxygen's a -2. 7 times -2 is -14. This is the dichromate ion, so the charges add up to -2. So what do I need here to make this -14 add up to -2? 12. +12 divided by 2 gives me a +6 is the oxidation number for chromium.